Hello, in this lecture we'll find out the length of line segment X using three different methods. In the drawing we have a triangle ABC, right triangle ABC. I repeat again, in this drawing we have a right triangle ABC. We know that angle ABC equals to 90 degrees, angle DAC equals to 45 degrees, side AB of triangle ABC equals to 6 units, here side DC equals to 10 units, and we want to find out the value of line segment AD that is actually equals to X. So we'll start with the first method. In the first method, we'll do a construction. We will extend line segment AD by a straight line. And then from point C, we will draw perpendicular to the extended AD. So this angle equals to 90 degrees, and this angle also equals to 90 degrees. And we will define the touching point of the perpendicular from point C and the extended AD is point E. And we will focus on the right triangle AEC. In the right triangle AEC, we know that the sum of the angles must be equal to 180 degrees. So here, which angles we have here? We have here 45 degrees, and we have here 90 degrees, and we have also here the missing angle ACE. In total, the sum of those three angles must be equal to 180 degrees. So here we will subtract 135 degrees from this equation, and we will get that the missing angle ACE, is equal to 45 degrees. So this angle equals to 45 degrees. We will define side DE as Y. We have the rule that in front of equal angles inside the triangle, there are equal sides. So here we have two angles in triangle AEC. We have two angles that are equal to each other. They are both equal to 45 degrees. Therefore, in front of those two equal angles, we will have equal sides. That is to say, side AE must be equal to side EC. So AE must be equal to EC. but we know that AE equals to x plus y. So we can write down that AE equals to x plus y. And from this equation, x plus y equals to AE equals to EC, we will derive that EC is also equals to x plus y. Okay, so we found out that here EC equals to x plus y. And we have those two angles are defined as vertex angles, and we know that vertex angles are equal to each other. So we can write down that angle BDA is equal to angle EDC okay, angle BDA equals to angle EDC. According to the rule that vertex angles are equal to each other. Okay, and if we define angle BDA as alpha, then from this equation we'll get that angle EDC is also equals to alpha. Angle EDC is also equals to alpha. So both those two angles are equal to alpha according to our definition. So here the triangle DEC is a right triangle, and this angle equals to alpha. Therefore angle DCE must be equal to 90 degrees minus alpha. Likewise, triangle ABD is a right triangle, and angle BDA, this angle equals to alpha. Therefore angle BAD must be equal to 90 degrees minus alpha. Actually, we proved that the two right green triangles are similar to each other. Why? Because they have equal angles. Those two angles, they are both equal to 90 degrees minus alpha. Both those two angles are equal to alpha, and both those two angles are equal to 90 degrees, they are right angles. So I'll write it down. In the right triangle, triangle ABD, and the right triangle, triangle DEC, we know that angle BAD is equal to angle ECD, and both angles they are equal to 90 degrees minus alpha. I'll repeat again. Angle BAD equals to angle ECD, and they are both equal to 90 degrees minus alpha. Angle BDA, this angle, is equal to angle EDC, this angle, and they are both equal to alpha. I'll repeat again. Angle BDA equals to angle EDC, and they are both equal to alpha. And we have angle ABD is equal to angle BEC, and both angles are equal to 90 degrees. Okay? Angle ABD equals to angle DEC, and they are both equal to 90 degrees. So we actually proved that triangle ABD is similar to triangle DEC according to angle similarity rule. I will write it down. We proved that triangle ABD is similar, this is the sign of similar, to triangle DEC according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will conclude that the following relationship exists between their sides. We will conclude that AB over EC is equal to BD over DE and it is equal to AD over DC. I repeat again, from the fact that the two grand triangles are similar to each other, we will conclude that AB over EC equals to BD over DE equals to AD over DC. AB is equal to 6 units. We will substitute AB by 6. EC equals to x plus y. We will substitute EC by x plus y. And it is equal to BD over DE. DE equals to y according to our definition. And it is equal to AD. AD is x according to what is given us in the question over DC. DC equals to 10 units. In conclusion, we found out that according to equation number 1, 6 over x plus y equals to bd over y equals to x over 10. In the next step, we will find out the value of bd. We will focus on the right triangle ABD. According to the Pythagoras theorem, here the letters PT is abbreviation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AD, so the square of the hypotenuse is AD squared, and it is equal to the sum of the squares of the perpendiculars. That is to say, it equals to AB squared plus BD squared I'll repeat again. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AD squared equals to AB squared plus BD squared. AD is equal to x, so AD squared will be equal to x squared. And it is equal to AB squared. AB equals to 6, so AB squared is 36 plus BD squared. So we found out that x squared equals to 36 plus BD squared. We will subtract 36 from this equation, and we get that BD squared equals to x squared minus 36. Here we take a root out of this equation, and we will get that BD is equal to the square root of x squared minus 36. Therefore, we can substitute BD in equation number 1 by square root of x squared minus 36. We will do it now, and we will get that according to equation number 1, 6 over x plus y is equal to BD, but BD, we already found out that BD equals to square root of x squared minus 36 over y, and it is equal to x over 10. So here we create two equations from this long equation. The first equation will be that 6 over x plus y is equal to x over 10. Here we will cross multiply equation number 1, and we will get that 6 times 10 is 60, and 60 equals to x times x plus y. We will open the brackets on this side of equation number 1, and we will get that according to equation number 1, 60 equals to x times y, x times x is x squared, plus x times y. We subtract x squared from this equation, equation number 1, and we get that we subtract x squared, so we get that according to equation number 1, xy equals to 60 minus x squared. So we found out that according to equation number 1, xy equals to 60 minus x squared. In the next step, we create another equation in this long equation. This will be equation number 2. According to equation number 2, we'll get that square root of x squared minus 36 over y is equal to x over 10. Here we'll cross multiply this equation, equation number 2, and we get that according to equation number 2, ten times square root of x squared minus 36 is equal to xy. So according to equation number 2, the value of xy is equal to 10 times square root of x squared minus 36. In the next step, we create equation number 3 that states that xy according to equation number 1 must be equal to xy according to equation number 2. So xy according to equation number 1 is equal to 60 minus x squared. And it must be equal to xy according to equation number 2. That is actually equals to 10 times square root of x squared minus 36. Here we will square both sides of equation number 3, and we get that $60 minus x squared is equal to 10 squared is 100, and the square and the root, the square cancels the root, and we're left only with x squared minus 36. So in conclusion, found out that according to equation number 3, 60 minus x squared equals to 100 times x squared minus 36. Here we'll open the brackets on both sides of equation number 3, and we get that according to equation number 3, 60 minus x squared equals to 60 squared, that is 3600, plus x squared, that is x to the power of 4, minus 2 times 60 times x squared, and it is equal to 100 times x squared is 100 x squared minus 100 times 36 is 3600. So here we will add 3600 to this equation, equation number 3. And we get that according to equation number 3, 3600 times 3600 is 7200. Plus x squared minus 2 times 60 is minus 120 times x squared, and it is equal to 100 times x squared. So here we subtract 100 times x squared from this equation, equation number 3. And we get that according to question number 3, x squared minus 120x squared minus 100 is minus 220x squared plus 70 200 equals to 0. Here we substitute minus 220x squared by 180x squared minus 140x squared, because of the fact that minus 180 minus 40 is equals to minus 220. And we get that according to equation number 3, x to the power of 4 minus 180x squared minus 40x squared plus 7200 equals to 0. Here we divide those big expressions to two expressions, and we will take a common factor of x squared out of those two expressions, and then we will take common factor of x squared from those two expressions too. So we'll start with the first expression. What is left from x to the power of 4 after we took from it x squared is common factor? What is left is actually x squared. And what is left from minus 180x squared after we took from it x squared is common factor? What is left is actually minus 180. And then from here we take a common factor of minus 40. So what is left from minus 40 after we took from it minus 40x squared as a common factor? What is left is actually x squared. And what is left from 72 100 after we go from it minus 40 is a common factor? What is left is actually minus 180. Why? Because minus 180 times minus 40, it is equal to 7200. So here we took x squared minus 180 is a common factor, and we get that x squared minus 180. So what is left from this expression after we took from it x squared minus 180 is a common factor? What is left is actually x squared. And what is left from this expression after we took from it x squared minus 180 is a common factor? What is left is actually minus 140, and it must be equal to 0. So here we have two solutions that are possible for x. The first solution is that x squared minus 180 equals to 0. And the second solution is that x squared minus 40 equals to 0. And we focus on the first solution. According to the first solution, x squared is equal to 180, and 180 is 36 times 5. Here we take out of this equation number 1, and we get that going to equation number 1, x equals to the square root of 36 times 5. So the square root of 36 is 6, and inside the brackets what is left is actually 5. So we found out that according to the first solution, x equals to 6 times square root of 5, that is actually equals to 13.41 units. That is actually greater than 10. So according to the first solution, x equals to 13.41 units, that is greater than 10. Then we have also the second solution to the possible for x. The second solution for x is that x is equal to 180. Here we take a root, x squared is equal to 180. Here we take a root out of this equation number 2. And the second solution is x squared equals to 40, of course. X squared equals to 40. Here we take a root out of this equation number 2, and we get that x, according to equation number 2, x equals to the square root of 40. 40 is 10, 4 times 10. And the square root of 4 is 2. So we found out that x equals to 2 times square root of 10 units. We will check which of the solutions is correct and it is relevant to our question. So I will copy triangle ABD and triangle ADC that are adjacent one to each other. And so we have triangle ABD, the right triangle ABD. We know that angle BAD equals to 90 degrees minus alpha, so we will define it as theta, and this angle equals to alpha. I will copy triangle ADC also to the new page. So we have triangle ABD and triangle ADC. Here we know that AD equals to X units and DC equals to 10 units. And actually, triangle ABD, the right triangle ABD is 3 interior angles. Angle theta is the first interior angles. This angle is equals to 90 degrees is the second interior angles of triangle ABD, and angle alpha is the third interior angle. And we also have here in the drawing the exterior angle ADC. So actually angle ADC, this angle is an exterior angle of triangle ABD. Okay, I write it down. Angle ABD is the exterior angle of triangle ABD. Angle ADC, this angle is an exterior angle of triangle ABD, the right triangle, triangle ABD. And we have rule number 1 that relates to the size of an exterior angle. According to rule number 1, an exterior angle in a triangle is equal to the sum of the two interior angles that are not adjacent to it. I read rule number 1 again. According to rule number 1, an exterior angle in a triangle is equal to the sum of the two interior angles that are not adjacent to it. And I already mentioned that the green triangle has three interior angles: angle theta, angle alpha, and this angle that is right angle. And the two interior angles that are not adjacent to this angle, angle ADC, are theta and 90 degrees, because angle alpha is adjacent to angle ADC. So those two angles, theta and 90 degrees, are not adjacent to the exterior angle, angle ADC. And according to rule number 1, theta, or 90 degrees plus theta, is the size of the exterior angle, angle ADC. Okay? And we know that the sum of the angles in any triangle is equal to 180 degrees, and especially in triangle ADC, the sum of its angles must be equal to 180 degrees. So which angles we have in triangle ADC? In triangle ADC, we have this angle that is equal to 45 degrees, plus this angle that is equal to 90 degrees plus theta, plus this angle that is equal to angle ACD. In total, the sum of those three angles must be equal to 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. Here we will subtract 135 degrees from this equation, and we will get that angle theta plus angle ACD equals to 180 degrees minus 135 degrees is 45 degrees. So here we will subtract theta from this equation, and you will get that the missing angle, angle ACD, is equal to 45 degrees minus theta. Okay, so we found out that the missing angle here is equal to 45 degrees minus theta. Actually, we found out that this angle, angle ACD, that is equal to 45 degrees minus theta, is the smallest angle in triangle ADC. I will write it down. From a drawing, we can see clearly that angle ACD, that is equal to 45 degrees minus theta, is the smallest angle of triangle ADC. I'll repeat again. Angle ACD that is equal to 45 degrees minus theta is the smallest angle of triangle ADC. And we also have rule number 2. According to rule number 2, the smallest angle in the triangle is always in front of the shortest side. I write it down. The smallest angle in a triangle always in front of the shortest side. I read rule number 2 again. According to rule number 2, the smallest angle in a triangle is always in front of the shortest side. So here, according to rule number 2, the smallest angle, this is actually this angle ACD, that is equal to 45 degrees minus theta, is in front the shortest side of the triangle. So here we will get that X is the shortest side in triangle ADC. Therefore, X must be less than 10 units. Okay, X is less than 10 units. Here, you can derive from rule number 2 that angle, that side X that is in front of the smallest angle, it is the shortest side. Therefore, X is less than 10 units. According to rule number 2, X is less than 10 units. According to rule number 2. We add two solutions for X. The first solution is X equals to 6 times square root of 5. That is equal to 13.41 units. That is greater than 10. But according to rule number 2, X is less than 10. And this solution gives us X that is bigger than 10. So this solution is incorrect solution. We will cancel this solution and we left only with the solution that X is equal to 2 times square root of 10. That is actually equals to 6.32 units. That is less than 10. Therefore, this is the solution to the question, that the value of the length of line segment X, that is AD, is equal to either 10 times square root of 10 units or 6.32 units. We finished with the first method. In the next step, I present to you how to find out the length of line segment X that is equal to AD according to the second method. Okay. In the second method, we will do a construction, another construction. From point D, we draw straight line on AC in such a way that the angle that will be created is equal to 45 degrees. So the straight line is drawn in such a way that this angle equals to 45 degrees. So this is according to our construction. So this point is A. So we draw the straight line from point D on AC in such a way that angle AED is equal to 45 degrees. Okay? And in triangle ADE we have two equal angles. Both of those two angles are equal to 45 degrees. And we know that in front of equal angles in the triangle there are equal sides. That is to say, AD must be equal to DE. AD must be equal to DE. But AD equals to X according to what is given as the equation. So from this equation, X equals to AD equals to DE, we derive that DE is also equals to X. DE is also equals to X. Okay? In the next step, we will define angle BAD as theta. So if angle BAD in the right triangle BAD is equal to theta, then this angle must be equal to 90 degrees minus theta, of course. And we also know that the sum of the angles in triangle ADE must be equal to 180 degrees. Which angles we have in the in triangle ADE? We have here 45 degrees. We have here 45 degrees, and we have here angle ADE. In total, the sum of those three angles must be equal to 180 degrees according to the rule that the sum of the angles in any triangle is equal to 180 degrees. We will subtract 90 degrees from this equation. We have 90 degrees on. We subtract 90 degrees. 45 degrees plus 45 degrees is 90 degrees, so we'll subtract 90 degrees from this equation. 180 degrees minus 90 degrees is 90 degrees. So we found out that the missing angle ADE, equals to 90 degrees. Angle ADE equals to 90 degrees. Okay. So here a right angle, angle ADE is a right angle. It is given us in the question that triangle ABC is a right triangle, and therefore anyway BC is one side of a triangle, therefore it is absolutely a straight line. Okay, side BC, line segment BC is one side of triangle ABC, therefore it is absolutely a straight line if a side is a side of a triangle. BC, line segment BC is a straight line. Because it is one side of triangle ABC. It must be a straight line. And we have the rule that the sum of the angles on one side of a straight line equals to 180 degrees. So if we focus on the upper side of the straight line BC at point D, then the sum of the angles according to the rule that I mentioned must be equal to 180 degrees. So which angles we have at the upper side of the straight line BC at point D? We have here one angle that is equal to, here at point D, on the upper side of the straight line BC at point D, we have one angle that is equal to 90 degrees minus theta. We have also one angle that is equal to 90 degrees. And we have the missing angle EDC. In total, the sum of those three angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Okay, so on the upper side of the straight line BC at point D, the sum of the angles must be equal to 180 degrees. Okay, so the first angle that is 90 degrees minus theta plus the second angle that is 90 degrees plus the third angle that is angle EDC. In total, the sum of those three angles must be equal to 180 degrees. Here we have 90 degrees minus 90 degrees plus 90 degrees is 180 degrees, and we have 180 degrees on both sides of the equation. So we'll subtract 180 degrees from this equation, and we get that 180 degrees will get cancelled, and we're left only with minus theta plus angle EDC is equal to 0. Here we will add theta to this equation, and we will get that angle EDC, the missing angle, is equal to theta. Angle EDC equals to theta. The missing angle here equals to theta. Okay, in the next step, from point E we will draw perpendicular on BC. I repeat again, from point E we will draw perpendicular on BC. So this angle equals to 90 degrees, and this angle is equal also to 90 degrees according to our construction. And we will define the touching point of the perpendicular from point E and BC as F. So in the right triangle EDF, if this angle equals to theta, then this angle must be equal to 90 degrees minus theta. Okay? So actually we found out that all the angles of the right triangle ABD are equal to all the angles of the right triangle EDF. And more than that, we actually will prove that the two right triangles can go into each other. Why those two right triangles can go into each other? So I'll write it down. We'll focus on the right triangle ABD, and the right triangle EDF. Why those two right green triangles can go into each other? First of all, those two angles are equal to each other, they are both equal to theta. Angle BAD here is equal to angle EDF, this angle, and they are both equal to theta. I repeat again, angle BAD equals to angle EDF, and they are both equal to theta. Side AD equals to side DE, and they are both equal to X. AD equals to DF, and they are both equal to X. Again, I repeat again, AD equals to DF equals to X. And finally, those two angles, they are equal to each other. They are both equal to 90 degrees minus theta. So angle ADB is equal to angle DEF, and both angles are equal to 90 degrees minus theta. So we actually proved that the right green triangle, triangle ABD, is congruent to the right green triangle, triangle EDF, according to angle side angle rule. We have those two angles, they are equal to each other, those two sides are equal to each other, and those two angles are also equal to each other. So we can write down that the right triangle, triangle ABD, is congruent. This is the sign of congruent to the right triangle, triangle EDF, according to angle side angle rule. And from the fact that those two right green triangles congruent to each other, we will conclude, hence, we will conclude that AB is equal to DF, and side AB equals to side DF, according to the rule that corresponding sides and congruent triangles are equal to each other. Those two green triangles congruent to each other. Therefore, the corresponding sides, that is to say AB and DF, will be equal to each other. Okay? But it is given us in the question that AB equals to 6. So we can write here that AB is equal to 6. And from this equation, 6 equals to AB equals to DF. We will derive that DF is also equals to 6 units. DF is also equals to 6 units. So we can write here that DF equals to 6 units. And likewise, we will conclude for the same reason that side BD equals to side EF. Side BD is equal to side DF, according to the rule that corresponds to side EF. Side BD equals to side EF, according to the rule that corresponding sides and congruent triangles are equal to each other. Exactly according to the same rule. And if we define side BD as Y, here side BD is equal to Y according to our definition. So from this equation, Y equals to BD equals to EF, we will derive that side EF is also equals to Y. So we can write down here that side EF is equal to Y. Okay? What is the value of FC? The value of line segment FC, it is very easy to see from the drawing that the value of FC it is actually equals to DC minus DF. I repeat again, DC minus DF equals to FC. So FC is equals to DC, that is 10 units, minus DF that we just right now found out, that is 6 units. So FC equals to 10 minus 6, that is 4. So we found out that FC equals to 4 units. So we can write here that FC equals to 4 units. And in the next step, we will prove that the right triangle ABC is similar to the right triangle, triangle EFC. Okay? So, why those two triangles are similar to each other? I'll repeat again. We prove that triangle ABC is similar to triangle EFC. So why those two triangles are similar to each other? First of all, they both have right angles. Those two angles, they are both right angles, therefore they are equal to each other, of course. So angle ABC in triangle ABC is equal to angle EFC. In triangle EFC, they are both equals to 90 degrees. I repeat again. Angle ABC is equal to angle EFC, they are both equal to 90 degrees. In addition, this angle is a common angle, it belongs to both triangles. So we can write down that angle BAC is equal to angle BCA. Actually it is angle BCA. This is angle BCA is equal to angle FCE and those angles are equal to each other because of the fact that this angle is a common angle, it belongs to both triangles. And finally, angle BAC, this angle will be equal to angle FEC, this angle. And those two angles, they are equal to each other according to third angle theorem. According to third angle theorem. Okay? So, what is third angle theorem? Third angle theorem is that if you prove that two angles in one triangle are equal to two angles in another triangle, then the third pair of angles must also congruent because they are complementary to 180 degrees. Okay, so we actually found out that all the angles of triangle ABC congruent to all the angles of triangle BAC. All the angles of triangle ABC congruent to all the angles of triangle EFC or ECF. Okay? Therefore, we can write down that triangle ABC is similar, this is the sign of similar, to triangle EFC or ECF according to angle similarity rule. Okay? And from the fact that triangle ABC is similar to triangle FEC or EFC, we'll conclude hence that AB over BC is equal to EF over FC. I repeat again, from the fact that triangle ABC is similar to triangle EFC, we will conclude that AB over BC equals to EF over FC. AB is equal to 6 units, BC is equal to Y plus 10. You can see here that BC is equal to Y plus 10. And it is equal to EF. EF equals to Y over FC. FC equals to 4. So, in conclusion, we found out that according to equation number 1, 6 over Y plus 10 equals to Y over 4. Here we will cross multiply this equation, equation number 1, and we'll get that according to equation number 1, 6 times 4 is 24, and it is equal to Y times Y plus 10. Here we will open the brackets, and we'll get that according to equation number 1, 24 equals to Y times Y is Y squared plus 10Y. Here we'll subtract 24 from this equation, equation number 1, and we'll get that according to equation number 1, we'll have here a quadratic equation. We'll get that according to equation number 1, Y squared plus, it's 10Y of course, plus 10Y minus 24 equals to 0. So here we got the quadratic equation, and the general form of quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X is actually equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, the coefficient a is equal to 1, the coefficient b is equal to 10, and the coefficient c is equal to minus 24. And the variable that we are looking for is y, so x equals to y. So here we'll put the data inside the equation for x, and we will find out the value of the values of y, because x equals to y. So we get that y is equal to minus b is 10, so minus b is minus 10, plus minus square root of b squared. B is 10, so b squared is 10 squared, 10 squared is 100, minus 4 times a is 1, times c is minus 24. So it is minus 4 times minus 24 over 2a. A is 1, so 2 times 1 is 2. So here we got that y is equal to minus 10 plus minus 4 times minus 24 is plus 96. So, and 96 plus 100 is 196. So inside the root we have 196 over 2. So we got that y is equal to minus 10 plus minus the square root of 196 is 14 over 2. So here we will have two solutions that are possible for y. The first solution is that y equals to minus 10 minus 14 over 2. Minus 10 minus 14 is minus 24 over 2 is minus 12. So we found out that according to the first solution, y is equals to minus 12. That is a negative number, but because of the fact that you can see here that y is the length of a side of a triangle, y is a length, and as a length it must be a positive number. So this solution is incorrect solution. We'll cancel this solution and we're left only with the second solution, that y is equal to minus 10 plus 14 over 2. Minus 10 plus 14 is 4, and 4 over 2 is 2. So we found out that y equals to 2 units. So here we know that y is equal to 2 units. So we copy the right triangle, triangle ABD, and we will implement the Pythagoras theorem on the right triangle, triangle ABD. On the right triangle, triangle ABD, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, x squared equals to 6 squared, that is 36, plus 2 squared, that is 4. So x squared equals to 36 plus 4 is 40. We take root of this equation and we get that x equals to the square root of 40. 40 is 4 times 10. And the square root of 4 is 2, so it is 2 times square root of 10. So in conclusion, we found out that the size of line segment x is equal to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. So we finished with the second method. In the next step, I will present to you how to find out the length of line segment x according to the third method. In the third method, we will define angle BAD, this angle is theta, and we will define side BD of the right triangle ABD as y. So here we will get that triangle theta in triangle the right triangle, triangle ABD. We will get that triangle theta equals to y over 6. And if we focus on the right triangle, triangle ABC, in this right triangle, we will get that triangle 45 degrees plus theta is equal to y plus 10 over 6. Okay? And we actually have trigonometric identity for the value of tangent 45 degrees plus theta. According to this trigonometric identity, tangent 45 degrees plus theta equals to 1 plus tangent theta over 1 minus tangent theta. Okay? We use this trigonometric identity and we will substitute tangent 45 degrees plus theta by this expression in equation number 1. And we will get that according to equation number 1, this equation, tangent 45 degrees plus theta, it is equal to 1 plus tangent theta over 1 minus tangent theta. And according to equation number 1, this is equal to y plus 10 over 6. So here we cross multiply this equation number 1, and we get that according to equation number 1, but first of all, we have already found out that tangent theta equals to y over 6, so we substitute tangent theta, and we'll substitute tangent theta in equation number 1 by y over 6, because tangent theta equals to y over 6, and we get that 1 plus tangent theta, that is y over 6, over 1 minus tangent theta, that is also y over 6. It is equal to y plus 10 over 6. Here we multiply 1 both in the numerator and the denominator by 6, and then we divide it by 6 in order to have a common factor with y over 6 and with minus y over 6, and we get that according to equation number 1, here we will have 6 plus y over 6 minus y over 6 plus y over 6 plus 6 minus y over 6 is equal to y plus 10 over 6. Okay? So here we have 6 in the numerator and 6 in the denominator, so 6 will get cancelled. And what is left from equation number 1 after we cancelled 6? What is left is actually, here we have 6 plus y over 6 minus y is equals to y plus 10 over 6. Here we cross multiply this equation number 1, and we get that according to equation number 1, 6 times 6 plus y is equal to 6 plus y times y plus 10. We will open the brackets on both sides of equation number 1, and we get that according to equation number 1, 6 times 6 is 36, and 6 times y is 6y, and it is equal to 6y plus 60 plus y squared plus 10y. So here we have 6y on both sides of equation number 1, so 6y will get cancelled. And so what is left from equation number 1 after we cancelled 6y, what is left is actually here, in this side of the equation we have 36 is equals to 60 plus y squared plus 10y here actually we have, when we cross multiplied here, it is 6 minus y times y plus 10. It is not 6 plus y, but it is 6 minus y. So 6 times y is 6y. And 6 times 10 is 60. And here it is y squared minus y squared. Minus y times y is minus y squared. Minus 10y. So here we got that 36 equals to minus y to 60 minus y squared minus 10y. So we will add to equation number 1 y squared and 10y, and we get that according to equation number 1 y squared plus 10y plus 36 equals to 60. Here we'll subtract 60 from this equation number 1, and we'll get that according to equation number 1 y squared plus 10y, and 36 minus 60 is minus 24 equals to 0. So this equation is the equation that we have already solved according to the second method, and we already found out that the solution for this quadratic equation is either y equals to minus 12 or y equals to 2, and because of the fact that y is a length, it must be a positive number, therefore the solution that y equals to minus 12 is incorrect solution. We cancel the solution, and we left only with the solution that y is equal to 2 units. Then, so here we found out that y equals to 2 units. Then we implemented the Pythagoras theorem on the right triangle ABD. According to the Pythagoras theorem on the right triangle ABD, BD equals to 2, AB equals to 6, AD equals to X is the missing variable. According to the Pythagoras theorem by PT, Pythagoras theorem, we'll get that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. X squared equals to 6 squared, that is 36, plus 2 squared, that is 4. So x squared equals to 40. X equals to the square root of 40. 40 is 4 times 10, and the square root of 4 is 2. So we found out that x equals to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. In the next step, I will summarize the lecture. We'll start with the first method. So in the first method, in order to find out the value of line segment A, that is actually x, we made a construction. We extended side AD by straight line, and then from point C we drew perpendicular to the extended AD. So this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. And here in triangle AEC, the right triangle AEC, we know that the sum of the angles must be equal to 180 degrees in the right triangle AEC. So which angles we have here? We have here 45 degrees. We have here this angle that is equal to 90 degrees according to our construction. And we have here the missing angle, angle ECE. In total, the sum of those two angles must be equal to 180 degrees. We subtracted 135 degrees from this equation, and we got that the missing angle, angle ECE, equals to 45 degrees. So this angle equals to 45 degrees, angle ECE. Then we defined side DE or line segment DE as y. So AE equals to x plus y. So in the right triangle, triangle ACE, we have two equal angles. They are both equal to 45 degrees, and we know that in front of equal angles in the triangle, there are equal sides. So that is to say, because of the fact that those two angles are equal to each other, therefore AE must be equal also to EC. AE must be equal to EC. Here, AE must be equal to EC. But we know that AE equals to x plus y. AE equals to x plus y. So from this equation, x plus y equals to AE equals to EC, we derive that EC is also equals to x plus y. Here EC equals to x plus y. And here those two triangles and those two angles are equal to each other because they are vertex angles. And we have a rule that says that vertex angles are equal to each other. So those two vertex angles are equal to each other. That is to say, angle BDA is equal to angle EDC because of the fact that vertex angles are equal to each other. So if we define one angle as alpha, then the other angle will be also equal to alpha because they are equal to each other. Okay? So, because of the fact that in this right triangle, triangle ABD, this angle equals to alpha, then this angle must be equal to 90 degrees minus alpha. And because of the fact that in this right triangle, triangle DEC, this angle equals to alpha, then this angle must be equal to 90 degrees minus alpha. So we actually found out that those two right triangles are similar to each other. Why? Because, first of all, angle BAD equals to angle ECD equals to 90 degrees minus alpha. Those two angles are equal to each other. They are equal to 90 degrees minus alpha. Both of them, those two angles, they are also equal to each other. They are both equal to alpha. And those two angles, they are equal to each other. They are both equal to 90 degrees. So we found out actually that the right triangle ABD is similar to the right triangle EDC according to angle similarity rule. Okay? From the fact that those two right triangles are similar to each other, we will conclude that AB over EC equals to BD over DE, and it is equal to AD over DC. I'll repeat again. AB over EC equals to BD over DE equals to AD over DC. AB equals to 6, EC equals to x plus y. BD is BD and DE equals to y. Here DE equals to y. DE equals to y, as you can see in the drawing, D equals to y. AD is equal to x. It is given as the equation, and this equals to 10. Then we found out the value of BD by implementing the Pythagoras theorem on the right triangle, triangle ABD. Okay? Here the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say, x squared equals to 36 plus bd squared, or ad squared equals to ab squared plus bd squared. Ad is x, so ad squared is x squared, and it is equal to ab squared, that is 6 squared, that is 36, plus bd squared. Okay? Here we subtracted 36 from this equation, and we got that bd squared equals to x squared minus 36. We took out of this equation, and we got that the value of bd equals to square root of x squared minus 36. So we can substitute bd in this equation, equation number 1, by square root of x squared minus 36. We did it, and we got that 6 over x plus y equals to bd, that is the square root of x squared minus 36 over y, that is equal to x over 10. Here we created two equations from this long equation. The first equation is that 6 over x plus y equals to x over 10. Here we cross multiply this equation, equation number 1, and we got that 6 times 10 is 60, and then we have x times x plus y. We open the brackets here, and we got that x times x is x squared plus xy. Here we subtracted x squared from this equation, and we got that according to equation number 1, xy equals to 60 minus x squared. Then we created equation number 2, according to equation number 2, square root of x squared minus 36 over y equals to x over 10. This is equation number 2. And we cross multiply the equation number 2, and we got that x times y equals to 10 times square root of x squared minus 36. We squared both sides of equation number 2, and we got that in the next step, so this is equation number 2, so we have two expressions for xy, equation number 1 and equation number 2. Then we created equation number 3 that states that xy according to equation number 1 must be equal to xy according to equation number 2. Xy according to equation number 1 is 60 minus x squared, and the xy according to this equation, equation number 2, is 10 times square root of x squared minus 36, and xy according to equation number 1 must be equal to xy according to equation number 2. So this is exactly expression number 3. Here we squared both sides of equation number 3, and we got that 60 minus x squared is equal to x 10 squared, that is 100, and here the square cancels the root, and we left only with x squared minus 36. So in conclusion, we found out that according to equation number 3, 6 minus x squared equals to 100 times x squared minus 36. We open the brackets on both sides of the equation, and we got that 60 minus x squared is equal to 60 squared, that is 3600, plus x squared times x squared is x to the power of 4, minus 2 times 60 times x squared, and it is equal to 100 times x squared, minus 100 times minus 36 is minus 3600. Here we added 3600 to this equation, equation number 3, and we got that 3600 plus 3600 is 7200, and it is equal to x to the power of 4 minus 2 times 60 x squared equals to minus 120 times x squared, and it is equals to 100 x squared. Here we subtracted 100 x squared from this equation, equation number 3, and we got that according to equation number 3, x to the power of 4 minus 120 x squared minus 120 x squared minus 100 x squared is minus 220 x squared plus 7200 equals to 0. And then we divided minus 220 x squared to two expressions. Minus 220 x squared, it is equal to minus 180 x squared minus 40 x squared. And then we took a common factor from x squared minus 180x squared. We took x squared as a common factor, and inside the brackets, from this, what is left is x squared. From this expression, what is left? It is actually minus 180. And from those two expressions, we took minus 40 as a common factor. And inside the brackets, what is left? It is actually x squared minus 180. Because minus 180 times minus 40 is 7200. And all of this, this is actually equals to 0. Okay, it is equal to 0, of course. And then we took a common factor of x squared minus 180 from this expression. So what is left from this expression after we took x squared minus 180 as a common factor? What is left? This is actually x squared. What is left from this equation after we took from it x squared minus 180 as a common factor? What is left? It's actually minus 40. So in conclusion, we got that according to equation number 3, x squared minus 180 times x squared minus 40 equals to 0. So here we have two solutions that are possible for x. The first solution is that either x squared minus 180 equals to 0, and the second solution is x squared minus 40 equals to 0. So according to the first solution, x squared equals to 180, and 180 is 36 times 5. We took a root out of this equation, and we got that x equals to the square root of 36 times 5. The square root of 36 is 6, so inside the root we left only with 5. So in conclusion, we found out that according to the first solution, the value of x is 6 times square root of 5. That is equal to 13.41 units, that is greater than 10. And according to the second solution, x squared minus 40 equals to 0, that is to say x squared minus 40 equals to 0, that is to say x squared equals to 40. We took a root of this equation number 2, and we got that x equals to the square root of 40. 40 is 4 times 10. We took a root from these expressions, and we got that x equals to the square root of 4 is 2. So in conclusion, we found out that according to the second solution, x equals to 2 times square root of 10, that is about 6.32 units. That is less than 10 units. Then I copied triangle ABD with triangle ADC in this new page. And here, in relation to the right triangle, triangle ABD, angle ADC is an external angle. I'll repeat again, in relation to the right triangle, triangle ABD, ADC is an external angle of triangle ABD. And we have, so ADC is an external angle of the right triangle, triangle ABD. And we have rule number 1 that states that an external angle in a triangle is equal to the sum of the two interior angles that are not adjacent to it. So here it means that the value of the exterior angle ADC equals to the sum of the two interior angles that are not adjacent to it. The two interior angles that are not adjacent to it is theta and 90 degrees. That is to say, angle ADC equals to 90 degrees plus theta. And then we know that the sum of the angles in triangle ADC is equal to 180 degrees. So which angles we have here? We have 45 degrees, we have 90 degrees plus theta, and we have the missing angle, that is angle ACD. In total, the sum of those three angles must be equal to 180 degrees. We subtracted 135 degrees from this equation, and we got that the missing angle ACD equals to 45 degrees minus theta. So here you can see from the drawing that the smallest angle in triangle ADC is this angle ACD, that is equal to 45 degrees minus theta. Okay? Here, angle ACD, that is equal to 45 degrees minus theta, is the smallest angle in triangle ADC. And we have also rule number 2 that states that the smallest angle in a triangle is always in front of the shortest side. that is to say, this is the smallest angle in triangle ADC, therefore it must be in front of the shortest side, that is to say AD that is equal to X is the shortest side in triangle ADC. What does it mean? It means that X is less than 10, because it is the shortest time. It is the shortest side. It means that X is less than 10 units. Okay? X is less than 10 units according to rule number 2. So this solution that X equals to 6 times square root of 5, that is actually 13.41 units, that is greater than 10, is incorrect solution because of the fact that X must be less than 10 units. And here less is greater than 10 units, so this solution is not correct. We cancel this solution and we left only with the solution that X equals to 2 times square root of 10 units, that is actually 6.32 units. That is the answer to the question, that the value of the length of line segment X is equal to 6.32 units, or we can present it also as 2 times square root of 10 units. Okay, we finished with the first method. And then I presented to you how to find out the value of line segment X according to the second method. In the second method, we made another construction. Here, from point D, we drew a straight line on AC in such a way that angle AEC will be equal to 45 degrees. So angle AEC equals to 45 degrees according to our construction. Okay? So in triangle ADE, we have two angles that are equal to each other. And we know that in front of equal angles, there are equal sides. That is to say AD must be equal to DE. AD equals to DE, but we know that AD equals to X. So from this equation X equals to AD equals to DE, we will derive that DE is also equal to X. Okay? And in the right triangle ADE, we know that the sum of the angles must be equal to 180 degrees. Which angles we have here? We have here one angle that is equal to 45 degrees. This angle is also equal to 45 degrees. Plus the missing angle that is angle ADE. In total, the sum of those two angles must be equal to 180 degrees. Here we have 90 degrees in the side of the equation, we have 90, so we have 45 degrees plus 45 degrees. Here, so we subtracted 90 degrees from this equation and we got that the missing angle ADE equals to 180 degrees minus 90 degrees, it is 90 degrees. So we found out that triangle ADE is a right triangle, because this angle ADE equals to 90 degrees. Okay? Then we defined angle ABD as theta. This angle is equal to theta according to our definition, and because of the fact that triangle ABD is a right triangle and this angle equals to theta, this angle must be equal to 90 degrees minus theta. And this angle equals to 90 degrees, this is the missing angle. Okay? But because of the fact that ABC is a triangle, it is given us the question that ABC is a right triangle, therefore BC is one side of a triangle, and as a side of a triangle, BC is absolutely a straight line. BC is a straight line because it is one side of triangle ABC. And we know that the sum of the angles on one side of a straight line must be equal to 180 degrees. So according to this rule, we will get that if we focus on the upper side of the straight line BC at point D, then the sum of the angles on the upper side of BC at point D must be equal to 180 degrees. So which angles we have here at point D, and on the upper side of BC, we have here 90 degrees minus theta, we have here 90 degrees, plus angle EDF. In total, they must be equal to 180 degrees. at point D, we have one angle that is equal to 90 degrees minus theta, the other angle that is equal to 90 degrees, and the third angle that is equal to angle EDC. In total, the sum of those three angles must be equal to 180 degrees according to the rule that I mentioned. Here we have 90 degrees plus 90 degrees is 180 degrees, so we have 180 degrees on both sides of the equation, so 180 degrees will get cancelled, and we left only minus theta plus angle EDC equals to 0. We added theta to this equation and we found out that the missing angle EDC equals to theta. So this angle EDC equals to theta. And then from point E we draw perpendicular on BC and we define the touching point between the perpendicular from point E and BC is point F. So this angle equals to 90 degrees and this angle equals to 90 degrees. That is to say, triangle DEF is a right triangle. And because of the fact that this angle equals to 90 degrees, this angle must be equal to 90 degrees minus theta. Okay, then we proved that those two right-green triangles are congruent to each other. Right, those two right-green triangles congruent to each other. First of all, we know that those two angles are equal to each other, they are both equal to theta. We have side AD that is equal to side DE and it is equal to x. And we have also those two angles, they are equal to each other, they are both equal to 90 degrees minus theta. So actually we proved that the green triangles can go into each other according to angle side angle rule. We have angle, side, angle in both triangles that can go into each other, therefore those two triangles can go into each other according to angle side angle rule. And from the fact that those two triangles can go into each other, we will conclude that AB is equal to DF according to the rule that corresponding angles that can go into triangles are equal to each other. The two green triangles can go into each other, therefore the corresponding sides, that is to say AB and DF, will be equal to each other. So AB equals to DF, but AB equals to 6 units. It is given as an equation. So from this equation 6 equals to AB equals to DF, we will derive that DF is also equal to 6 units. DF is also equal to 6 units. Then, from the fact that those two green triangles can go to each other, we will derive that BD is equal to EF. BD is equal to EF, and if we define BD as Y, then BD equals to Y. From this equation Y equals to BD equals to EF, we will derive that EF is also equals to Y. So EF is also equals to Y. Okay? Then we proved that the right triangle, triangle ABC, is similar to the right triangle, triangle EFC. Why those two right triangles similar to each other are similar to each other? First of all, they have two right angles. Both triangles have two right angles. They have right angles. Those two angles, right angles, they are equal to each other, and they have also a common angle. So angle ABC equals to angle EFC equals to 90 degrees, and angle BCA equals to angle FCE. It is a common angle. And the third angle, the third pair of angles is also equal to both triangles according to the third angle theorem. Okay? Therefore, we actually proved that triangle ABC is similar to triangle EFC according to angle similarity rule, and from the fact that those two right triangles are similar to each other, we will conclude that AB over BC equals to EF over FC. AB over BC equals to EF over FC. AB equals to 6, BC equals to Y plus 10, EF equals to Y, FC equals to 4. We cross multiply it here, equation number 1, and we got that 24 equals to Y times Y plus 10. We open the brackets here, and we got that 24 equals to Y squared plus 10Y. We subtracted 24 from this equation, and we got that Y squared plus 10Y minus 24 equals to 0. We solved this equation and found out we got two solutions. The first solution is y equals to minus 12, but because of the fact that y is a length, it must be a positive number. Therefore, this solution is incorrect, and we left only with the solution that y equals to 2. Then we implemented, so y is equals to 2, so we implemented the Pythagoras theorem on the right triangle ABD. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, x squared equals to 36 plus 4. 36 plus 4 is 40, so we found out that x squared equals to 40. We took out of this equation and we found out that x squared equals to square root of 40. That is actually 2 times square root of 10 units, or 6.32 units. We finished with the second method. Then I presented to you how to find out the length of angle theta according to the third method. In the third method, we defined this angle as theta and this angle, this side of y as y. So here triangle theta equals to y over 6, and in the right triangle ABC, triangle theta plus 45 degrees equals to y plus 10 over 6. Okay? Then we have the trigonometric identity that states that tan theta plus 45 degrees equals to 1 plus tan theta over 1 minus tan theta. So we can substitute tan theta plus 45 degrees in equation number 1. By this expression we did it, and we got that 1 plus tan theta over 1 minus tan theta equals to, according to equation number 1, y plus 10 over 6. We have already found out that tan theta equals to y over 6. So we can substitute tan theta by y over 6. We did it, and we got that 1 plus y over 6 over 1 minus y over 6 equals to 1 plus 10 over 6. Then we multiplied 1 by 6, and then we divided by 6 in order to overcome a factor of y over 6 and minus y over 6, and we got that 6 plus y over 6 minus y over 6 equals to y plus 10 over 6. Here we have 6 in the numerator and 6 in the denominator, so 6 will get cancelled, and we got that 6 plus y over 6 minus y equals to y plus 10 over 6. Because multiply the equation number 1, and we got to this quadratic equation that y squared plus 10y minus 24 equals to 0. So here we solved this quadratic equation in the second method. We got two solutions. The first solution is y equals to minus 12, but because of the fact that y is a length, it must be a positive number, so this solution is not correct solution, and we left only with the solution that y equals to 2. Then we implemented the Pythagoras theorem on the right triangle ABD. According to the Pythagoras theorem, x squared equals to 36 plus 4. That is to say, 36 plus 4 is 40, so we found out that x equals to 40. We took out of this equation, and we got that x equals to the square root of 40. The square root of 40 is 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. I'll repeat again. According to the first solution, we got that the length of line segment x is equal to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. Okay, thank you very much.